that's what we were looking at on yesterday, 22nd. So I wanted you to finish off this exercise. We got quite a bit into it yesterday. So what I'll do is I'll point out a few of the ones that were quite tricky. If we can see there from question 18, you've got to think about that as x to the 0, and then you add 1 to it and so on. So a constant goes back to an x, but in differentiation, when you differentiate a constant, it goes to 0. So that's one of the confusions that happens with integration and differentiation. If we look at 20, never work with decimal indices, always convert it to fractions, and you're able to do that because, remember, the 2 over 5 means the fifth root, so you're looking at being able to do the root of something rather than having a decimal power. Right, how far did we get to? Did we get as far as 9? We got a little bit further than that, yeah? So can we check from sort of 10 onwards? Can you please check to see I haven't made any silly mistakes as well? Can you mark your own? If there's any questions, then please don't hesitate to ask me. I think 30. One of the key things, remember, if you look at question 13, dividing by a fraction is the same as multiplying by its reciprocal. So dividing by the minus a half is the same as multiplying by the minus 2 over 1. And that's a minus divided by a minus gives you a plus, so that's how we get plus 4. Moving on a little bit more, can you check 16, 17 and 18 please? Talk a little bit. Just check your answers on that, make sure you've got it okay. And question 18 especially, you have got a constant. When you integrate a constant, it becomes the variable again. Right, moving on then, looking at the last two. I've converted that to a fraction, and then it's to the minus 2/5. So minus 2/5 plus 1 is what I've done there in terms of 5 over 5. And then dividing by 3/5 is the same as multiplying by 5 and dividing by 3. And those are sort of exam standard questions that we're looking at for integration. Happy with that? Yeah, no questions. Good, okay. Right, moving on then, let's look at the example in 8.2. We don't just have single terms. We can have a full expression that has lots of x's that have got different powers on them, but all we do is apply integration to each of them. So we're asked to find y, so that's a key statement, find y when we've got dy by dx. And that suggests to us that we have to take dy by dx and integrate it. So again, we write that step, and we put the dx at the end because it's with respect to x. We add 1 to the power, divide through by the new power, so let's do that on everyone. And remember that plus c at the end. That plus c at the end is worth 1 mark. If you miss that out, you'll miss 1 mark in the exam. And that's simply because when you differentiate a constant, it goes to 0, and that might have had a constant of some sort, so we have to put it back in again. Okay? Right, we've got to simplify that, so you've got a method mark and an accuracy mark for that, and then on the next part we've got to simplify that fully. Oh, I've subtracted, haven't I? Yeah? On this one here, we add 1 to the power, and I've managed to subtract it, so it's going to be 3 over 2 divided by 3 over 2. Is that better now? Is that why you were puzzled? Yeah. Okay. I haven't made any other daft mistakes, have I? Right, okay. So if we simplify fully, we get 3x squared minus x to the minus 2 and then we're going to multiply by 2 and then divide by 3, which will give us 2, and then x to the 3 over 2 plus or c. If you wanted to, you could put it into the form where you need it for substitution. So if we put it into that form there, that's what we need when we do substitution, yeah? So we're going to pop in there substitution form. And that's required if we have a value of x that we need to pop in, and we can get a final answer. Any questions on that? Okay, what I'd like you to do then is on exercise 8b, we'll do question 1, the first column. That's the absolute bare minimum. And then on question 2, we'll do the first column as well. Okay? We'll give you about 5-10 minutes. Remember to write the integration sign as well, please, everybody. This class is so quiet when you're filming, it's unbelievable. Could I just say for the record, it's never as quiet as this. Oh, dear. You see one group's under the camera, and that's the one I need. That's really annoying. Can you just check the first one? Sure you've got that okay. Right, so we add 1 to the power divided through by the new power. Are you agreeing with me on that? Yeah, that's absolutely fine. Right, just keep going then. It'll take quite a while working with the fractions and things on this one. So the next one is C. like to check C with you just to make sure. And did you get something like that? Notice I've written in the substitution form at the end, and plus C, plus the constant of integration has to come at the end as well. I think the difficult part about that one was the 3 over 2 and then dividing by a half as well. So you've got to be able to do your fractions. If you need to do them at the side, that little bit of arithmetic, then please do so. So you get your method and accuracy mark for the first line, and then you'd have to tidy up in some sort of way to get your other accuracy marks. Okay?
Is it not a minus all the way through? It's minus the 2x, it's minus in the question.
What were you saying, Sophie, on this one? Have I copied that down wrongly?
I think so.
Is
Just
it?
minus.
Okay. Okay. And that, yeah, it's minuses throughout, thank you. So that should be minus there. Is that okay? And then because I'm dividing through by -1, the end one changes to a positive, yeah?
The questions are minus as well, so it just stays as a negative.
What, this part at the end?
No, at the top before you've integrated it.
That part there is a minus. Right, cheers. But then I'm going to get plus 6x to the -1, aren't I?
Yeah.
Yeah, that's fine. Thank you. Okay. We'll do E now. So we're going to add 1 to the index. And divide through by the new index. And if you want to put it in the form where we have positive powers, or you want to do some substitution, that's what we get. And then moving on to part G. So we're just working down the first column. Please let me know if I've made a mistake. Are we okay with the last one? Are you disagreeing? You're okay with that? We're okay with that. And this one's a little bit more complicated because we've got lots of fractions to deal with. So that's going to give me 4 there. The question will ask you for it in its simplest form. But it's up to you if you want to put it in this form at the end. You would only do that if you were substituting some values into it. So that's absolutely fine like that. You okay with that? Yeah. Right, the only difference with question 2 is that instead of finding y from dy by dx, you're finding f of x from f dash of x. That's the only difference, but we're doing exactly the same thing. So let me add another page in there. So if you look at question 2 together, the first one, this time we would write f of x is equal to the integral of 12x okay, have a go at doing the column on question 2. And see how we'll go with that as well. So these are up to exam standard already. first one. Same rule every single time. Add 1 to the power, divide through by the new power. And if you show this line in here, you're going to get a method mark and an accuracy mark, and then you've got to tidy it up. Okay, so as long as you can do that part, and then make sure your accuracy with your fractions and times and your powers are pretty good there as well. Does anybody have any questions? It's especially about dividing by fractions, isn't it? You've got to be able to do that. The other thing is, when you've got, say, further down it's minus 5 over 3, and you're adding 3 over 3, so it gives you the minus 2/3. So it's being able to do fractions in your head as well. It's quite useful. That's all GCSE work, hopefully. So that was first part. Second part, you can write it in the two different forms, they're both acceptable. What you'll find on an exam paper, and a mark scheme, it'll say OE, and that means or equivalent. So there's lots of different forms that you can write your answer, as long as you've tried to simplify them in some sort of way. That would just mean or equivalent. Then looking at part E, we're adding 1 to the power, so we're dealing with a lot of fractions here. So minus 1/3 plus 1 is 2/3. Divide through by the new power, and so on. Be careful of your signs there, because you've got a plus divided by minus, so overall you're going to get a minus there. So I would say watch out very carefully with your accuracy. And this form here is useful when we do substitution, because you can see we've put it in terms of roots. The fractional index has gone to roots and powers. And then on the last one, add 1 to the power, divide through by the new power. And straight away, what I've done there is I've just flipped this one and put it as 1 over x. So simplified it in one go, basically. If you need to do little workings at the side, then feel free to do so, that's absolutely fine. Do we have any questions?
Can you just go back up to safe?
Yeah, sure. So I'll go back up to see, can you see what's going on?
Yeah.
Okay?
I was just checking.
Right, okay. You happy with that?
Can you just go back down?
Yeah. To there?
No, just close it down.
That way?
No, that
That way, sorry, down the way. I'm going up. That way?
Yeah.
Yeah, okay. Okay with that, Caitlin, yeah? Okay. Right, so that's an exam type question that you could come across. And we are going to skip over the next part, 8.3, because we've done that anyway. It's all it's doing is introduce the integral sign, but I introduced it a little bit earlier. So those ones, they're absolutely fine, we can just leave that. I think what I might want to draw your attention to actually is if we look at, we've got another variable in there. So if we look at question 7, so this is on exercise 8C please, on page 9. If we look at question 7, the variable has changed to t, so all that would mean is the integral to get t is the integral of 2t squared minus 3t to the minus 3 over 2. And notice it says with respect to t. So you're treating t as the variable, and we go about it in exactly the same way. Add 1 to the power, divide through by the new power. I think I'll say f of t for that one. Function of t. Okay? So I'll say f of t is equal to that. You could say y in place of it instead, but it's not t. And we can tidy that up a little bit. So we get 2t cubed over 3. We're going to get a plus sign there because we've got a minus divided by minus. Dividing by half is the same as multiplying by 2, so that'll give me 6t to the minus a half, plus t plus c. Is that okay? So that's just to make you aware that instead of having x's and y's, we could have